This is the absolute last time I'm going to try this pseudo magnetic levitation bearing for a compass. The magnets on the end are north and south, and they would stick together if they came together in the middle. So they form a compass. So the left side is pointing north, we hope. And the magnetic bearing, the pseudo-magnetic levitation bearing, is these two ring magnets in the middle. And one is the one on top is glued to a piece of craft stick with a hole in it, and that little dowel in the middle is going through the hole. And the bottom ring magnet is glued on the piece of wood. And I had a lot of trouble with this, and I'm still having trouble because the ring magnets seem to want to align a certain way, even though they're opposite sides, their same facing sides are the same polarity, and they should repel, but they should turn freely, but they don't quite turn freely. They tend to align if you give them a certain amount of time to align. But what I'm going to show you is that if I turn the base, the disc magnets may not work so well as a compass, because they seem to interfere with the permanent magnets. Well, look now, it seems to be working. Let's try it some more. Yeah, I think we're onto something here. Left is the north. So it seems to want to point north. Let's give it a spin. And it will find its north. I guess you just have to hit on the right positioning of those compass magnets. What I had in mind was to use this for a statorless motor, but I won't talk about that too much now. The main thing here is I'm making a compass, and the bearing is this pseudo-magnetic levitation bearing, which you've seen in toys. It's just the two magnets repelling each other with a stick, keeping them from moving apart and falling on their sides. It works just like the Levitation toy, it's a magnetic bearing, but it can't move left, right, forward, and back. It can only twist. It can only rotate. It's a very low friction bearing, that's for sure. So it would be great if I could use this on a statorless motor, but it would I try to scale it up a little bit so that maybe it would be big enough to hold the statorless motor. If I built the statorless motor, I would definitely take more care in balancing it right and making it a little sturdier. You can see by this it's a little shabbily built. But let me give it another twist. Now there's a little friction, so that made it turn, but it may come back to north. It seems like it doesn't want to come back to north now. You can see what I'm talking about. You see it's pointing a little northeast now. I don't know. I'm not happy with it. But it could be just that these are cheap ring magnets. They're ceramic ring magnets that I got for like $6 a piece at the hardware store. And maybe neodymium magnets would work better. but they seem to be plenty powerful for this little setup. I mean, there's about over an inch between them, repelling, and that's quite a lot of weight there. But you can see now it's pointing almost well northeast of where it should be pointing. So let's turn it some more. Eventually, when we turn it enough, it'll point north again. Yeah, it's coming back. Now that's as far as it's going to go. Let's keep turning it. There we go. So you can see there's a relationship between those two ring magnets that's making them line up a certain way. So if you're going to use this for a frictionless motor, I think you have to take that into consideration. For most intents and purposes it would be great, but I really need low friction for this to work at all. And I also need something low friction without magnetic interference for it to make a compass. So, but it works a little. But that's all I got for now. Thanks and stay tuned.